Okay, hello friends, welcome to my lecture. This is electrical circuit tutorial. So today I'm going to show you how to find a current flowing through a circuit and a voltage across each resistor by using the second basic type of laws, which is Kirchhoff law. Kirchhoff formulated two basic laws that are Kirchhoff current law and Kirchhoff voltage law. So let's see one by one. So Kirchhoff current law, that is KCL, states that the algebraic sum of a current entering a node or a closed boundary is zero. Yes. So node means here it is. Node, it is a point in which two or more elements are connected. Yes. So if we take this as an example, there are three current elements and they are connected here. So we can take this point as what? A node. Yes. So node means it's a point in which two or more elements are connected. So this law, what you call KCL, it says that the algebraic sum of current entering a node or closed boundary is zero. And mathematically, KCL implies that summation of I n which starts from 1 up to n is equal to 0. So if we take this as an example and we have assigned this node as A, so for node A, KCL, yes, if we apply KCL for this circuit, KCL, yes, since I1 it is entering into n node A, so it can be signed as positive. Okay, positive I1 minus, because I2 is it's leaving from a node A and it can be signed as I2, okay, minus I2 plus I3 minus IT. That means a total current flowing through the circuit IT, and it can be signed as negative since it is leaving from what? A node A. Okay, so this can be rewritten. Okay, actually I missed 0 here. So a current entering to a node and a current leaving from a node, and if take a sum of these elements can be what? 0. Yes. So from this I1 plus I3 yes equal is what? I2 plus IT. So this indicates that a total current entering into a node that are I1 and I3 are equal with what? A total current leaving from what? A node A that are I2 and IT, and this can be rewritten as IT. Yes, if we are going to write as one current source, I1 plus I3 minus what? I2. Okay, so a total current flowing through this circuit can be obtained as I1 plus I3 minus I2, and it can be represented as a single current element like this. Okay, so this arrow indicates that a current is flowing such like IT. Okay, so IT can be calculated as I1 plus I3 minus I2. And here it is a second law which formulated by Kirchhoff, that is what? Kirchhoff voltage law, KVL. Yes. So it states that the algebraic sum of all voltages around a closed loop, or we can say a loop, is 0. Yes. So mathematically this implies that summation of voltage across a closed loop, that is Vm, which m is starts from 1 up to m, equal with 0. So if we take this as an example, here it is a simple circuit, which is I, if we take a current flowing through this circuit as I, so if a current is entering in a negative terminal, a voltage is signed as what? Negative. So the algebraic sum of these voltages are 0. Yes, so for this one, since a current is entering in a negative terminal, so it can be signed as minus. That means minus V1, okay, minus V1 plus V2, because for this resistive terminal, the current is entering what? In a positive terminal, and it can be signed as positive. V2 plus V3 minus V4, because for this terminal, the current is entering in a negative terminal, and it can be signed as negative plus what? V5 equal with what? 0. Since KVL states that the algebraic sum of the voltage across each element is equal to what? 0. So if we apply a KVL for this circuit, can be what? Like this, okay? So from this equation, V1 plus V4 equal with what? Yes, V2 plus V what? V3 plus a voltage across the fifth element, that is what? V5. So you can find out a voltage across each terminal or a current flowing through each terminal just by using this Kirchhoff laws. Okay, so here it is an exercise. So it says find a voltage V1, that means a voltage drop across this resistor, and V2, that means a voltage drop across this resistor. Yes, just by using what? Two basic laws that are Ohm's law, which says that a voltage across a resistor, it is directly proportional to what? A current flowing through a resistor. Yes, so from Ohm's law, we can have a formula for what? Voltage. Yes, voltage can be calculated as a resistance of a resistor just for the first element, that is what? 4. Yes, 4 times a current flowing through this. Yes, we can assign a direction of a current like this. Yes, so we can take this as I. Okay, so 4 times what? I. And what about V2? Since these both resistors are connected in series, so we have what? The same current, because for series circuit, a current flowing through each element is what? Same, yes. So V2 also what? V2 is what? Minus, since a current is what? Entering in a negative terminal. So the direction of the current for the circuit is like this. So as it is a current I, it is entering in a negative terminal for this element. So it can be calculated as what? Minus 2 times I. Okay, so from Ohm's law, we have obtained what? A formula for two voltages that are V1 and V2. And from Kirchhoff laws, we can use what? KVL. Yes, KVL. From KVL, the algebraic sum of voltage across a closed loop equal to what? 0. So for the circuit, KVL can be applied. So this current I, it is entering in a negative terminal for this, so it can be signed as what? Minus 10. Okay, minus 10 volts plus For the first resistance, current it is entering in a positive terminal, so it can be what? V1 is V1 minus 8 volt, because current I is entering in a negative terminal, minus what? V2. So we have two equations here. Now just we can find out a voltage across each resistance just by what? Replacing the value of this voltage in equation 2 what? Yes, so from equation 2, just I see 0 here because a voltage, the algebraic sum of a voltage across a closed loop is 0. Yes, so if we substitute a value of V1 and V2 on this equation, we have what? Minus 10 minus 8, that is minus 18. Minus 18 volt. Yes, plus V1. V1, that means what? 4s, so plus 4 times I1. That means I. Yes. Minus V2 is, yes, V2 it is already obtained as 2I, yes, minus 2I, just minus times minus, it's plus, yes. So we can have what? Plus 2I. Yes, so this equation equal to what? 0. And this can be simplified as, yes, 6 times I equal with what? Equal with 1/8, that means 18. Yes, so a current flowing through this circuit can be calculated as just by dividing 18 by what? 6. So 18 over 6, that means what? 3 ampere. Yes, so a current flowing through this series circuit is calculated as what? 3 ampere. So now we can have what? A formula for V1 and V2. So just you can find out a voltage V1 just by replacing the value of I. So V1 can be calculated as what? 4 times, yes, 4 times I, that means 3. Is what? 12 amp, as well as 12 volt. So a voltage drop across the first resistance, that means across 4 ohm, this one calculated as 12 volt, and V2 can be calculated as minus 2 times I1, that means 3, yes. So this can be calculated as minus 6 volt. Okay, so here it is, a value for voltage V1 and V2. So this is an end of my today's lecture. So please try to like, share and subscribe my channel to get more videos. Thank you for watching. See you on my next video.